Hello, everyone. Thank you for joining us for our April webinar, 5 Ways to Crash Your QAD Database. I'm Denise, and I'm excited to have Nectar from OmegaServe with me today as our guest presenter. Nectar has prepared for us a fun and engaging presentation, which I will get you to after some very, very quick housekeeping. Everyone should have a control panel similar to the one I'm displaying. Please know that you connect to the webinar muted by default, but your questions or comments can be entered at any time throughout the session, right where that big red arrow is pointing. And then during the Q&A, we will run through the questions in the order received. Also, when you exit today's session, a quick survey will pop up automatically. Feedback, of course, is really helpful, so thank you in advance for any feedback you do take a moment to provide. And finally, as soon as the recording of today's session is published, I will send out to everyone our encore email. The blue Go to Replay button you see here, or you should see here, will take you directly to the webinar replay page. And now let me get you to the main event. Just one moment. And okay, sorry about the delay. Here we go.
Hello, everyone. Before we begin, let me just tell you a little bit about myself. My name is Nectar Daloglou. I'm the president of OmegaServe. I'm also a senior DBA, working and specializing in Progress and QAD for well over 20 years, since 2000. I'm also a regular speaker at the Progress and QAD user group conferences, and throughout the years, I performed many specialized services, particularly around the database administration side, at more than 100 different Progress customer sites. And I've seen my fair share of database crashes. And I'm eager to share these with you so that you don't experience these crashes and you don't have users coming up to you with pitchforks and your boss knocking on the door and asking you, what's going on? Why is the database down? So these are problems I want you to avoid. Now, just to tell you a little bit about OmegaServe, we are a North America-based managed DBA services company. We offer 24/7 monitoring and support and database consulting services, pretty much anything around the database, including migrations, health checks, performance tuning, business continuity strategies, disaster recovery, etc., with a particular focus on QAD. Our goal basically is to maximize uptime and performance. We're also an official reseller of a database monitoring software, arguably the best monitoring software for your QAD in Progress environment, called Protop. And if you happen to have the expertise in-house, you don't necessarily need to use our services. You can also use Protop. We also offer the tool if you have that expertise in-house. Now, why should we care if the database crashes? Why are you in this session? Well, there could be a significant cost to the business when an outage occurs. At the very minimum, there's a salary cost of all the users waiting to get back on the system, but then there's loss of productivity, delayed orders leading to fulfillment penalties, and damage to the company's reputation. Now remember, this presentation is about showing you stuff not to do, so please, don't try this at home. I know there's some curious ones, Nectar showed me how to crash the database this way, let's do that. No, please don't do it, especially not in production. And as I mentioned before, I want you to learn from mistakes of others. You'll learn from other people's bad experience and not repeat those mistakes that others have done. And my goal throughout this presentation, if I could show you at least one way to prevent a crash, then I feel like I've done my job, that I've served my purpose. So that is my goal. Now, crash number 1, human error. What's a human error? Very simple. You perform action A, expect outcome B, but whoops, you get outcome C. And it's a very bad outcome. It's a crash your database outcome. In short, it's a deviation from your original intention or expectation or desire out of that particular task that you're doing. And we're human, right? Everybody makes mistakes. But when we're working on a production environment, we have to be extra careful, and we have to manage these mistakes. We have to recognize that we're human and do whatever we can to help avoid these human errors. And we could break these down to a skill-based human error. So basically a slip of the action, a fat thumb moment, or a lapse of memory. And this can happen on any experienced DBA. It can happen if you have too much things on your plate, if you got an interruption, a phone call in the middle of your very important production task, and you have a fat thumb moment. Another type of human error is not following protocol, not having a checklist or a written procedure when you're doing that work in production. And I've seen this happen many times, unfortunately. I mean, even experienced pilots will still go through all the checklist because they cannot make a mistake. They cannot have that crash. Or it could be a knowledge-based mistake, not having enough knowledge about it. So, maybe you saw one of my OpenEdge replication presentations and you're like, oh, I can do this. Very simple. You do it very quickly in dev and test, and you do it in production, and then whoop, you get into trouble. So, don't do that. Make sure you inform yourself very well. You make sure you get the proper training, read the proper documentation, and you can avoid these types of human errors. Now here's some examples, some good examples of some human errors. So over here, the intention was to remove all the .ds. So recently performing a dump, and we're finished with that dump. We have our .d files. Let's remove our .d files. But whoops, we happen to be in the database directory, and we erased the .db, the .d1, and basically all your database extents are gone. So good news is you have a bunch of free space available that you didn't have before. Bad news is that you just deleted your database. Whoops. On the other RM command, this one will actually return an error. So we're removing, based on a wildcard, remove star space .d star. So the original intention was star.d star, but because of that space, we're going to get an error message saying, whoop, can't find the .d star. But really, we unintentionally removed all the files in that particular directory. Then this was an interesting one I heard before. So somebody wanted to remove the dev environment and accidentally removed all the dev files in the dev file system. Then there's the unintentional file redirect. So that greater than symbol, this is often in a command prompt, and that can be very dangerous if you're copying and pasting your previous command, or from another window, or from a checklist, or from wherever. Having that greater than symbol effectively wipes out that file. So very dangerous. So how do we manage a risk like this? Well, real simple. Make it a rule for yourself, always, whenever you're using, especially if you're using wildcards, always list out what you're about to remove. So run an ls command. And second thing, always check which directory you're at. Even better if you can have your directory displayed in your command prompt and know your working directory. If not, always check beforehand before running these dangerous RM commands. And keep in mind, if you're logged in as a privileged user, as the MFG user or as root, keep in mind that the power that you hold, and be very extra careful when running these commands. This is one of my favorite fat thumb moments. So imagine logging into a Windows server, doing all the work you need to do, and then going to sign out, and then whoops, accidentally hitting shutdown, because the shutdown option is just so close to the sign out option. Very dangerous. Another thing that happened that I've seen was an accidental server decommission. So in this particular case, there was a communication breakdown, and the infrastructure team forgot to check with the QAD team on whether or not a particular server is still in use. So what happened was, one day the QAD stopped working. At first no one knew why, but it wasn't very pleasant. And these days with virtual machines, everybody's running virtualized machines. It's so easy to just turn the power off, to just point and click. So be very careful. In Protop, there's a heartbeat feature where it actually expects a heartbeat from a server. If it doesn't receive that heartbeat, then it sends out an alert. And like many good monitoring systems have that feature, make sure that you have that feature enabled. Now here's one of my favorite. So this is a typical DBA task. We're disconnecting a user here. So we're responding to a user disconnect. And in this particular one, we see a process here, Nectar. Nectar's been logged in since 2016. He's a hardworking guy, this Nectar. But we need to disconnect him. So let's hit 1 here. Whoops! Shutdown is executing. What the hell happened? Well, the disconnected user and the shutdown is basically one button away, one fat thumb away. So how do we mitigate this risk? So a couple of ways. First way, we can remove the number 2 key from our keyboard, or make sure you run a proshut db list command. So run your proshut command, list out who you're about to disconnect. Don't just run that proshut menu where you can accidentally fat thumb the number 2. Second way to crash a database is by doing something like a user process kill. So killing a user process that's connected to a database. So improperly doing so, it could lead to an abnormal shutdown and crash a database. Now in Unix, there's different kill signals you could send to a process. Some of them are safe, some of them are not. For example, an interrupt signal is generally safe. A kill -9 is, or a -9 is not a good thing for a process. Especially if that process is holding on to a latch. That will most definitely bring the database down. In Windows, you don't have that flexibility of choosing what kill signal to send to a process. You pretty much have a kill -9 in Windows when you're doing a Windows end task on a process. Now just to be clear, this crash can happen only on local shared memory or self-service clients, basically a non-remote client. If you kill a remote client on another server, you don't have that risk of bringing the database down. But when you're killing a process on that database server, then there is risk of bringing the database down. Now there is a safe way to disconnect a user, as I showed you earlier, and safe ways to even kill the process. But this is beyond the scope of the presentation. But I'm going to show you some examples that can kill a database. Within OpenEdge Explorer or OpenEdge Management, you have the option of terminating a web speed agent or an app server agent. A nice little convenient little kill button. It looks pretty innocent. It's in a progress interface. It's made by Progress. If you go and click on that button, you're going to have a really bad day. So do not kill your agent processes this way. If you're running .NET UI, you're most definitely using app server web speed agents. Do not go in and terminate them this way. Bad idea. The next couple of examples are Windows examples. So in Windows, this is very different behavior than Unix, which I learned the hard way early on. If you're running a database connection within a window and you decide to close that window, that's essentially the same thing as doing an end task. And if you're holding on to a latch, you're going to crash your database. A similar behavior when you're logging out of Windows. So maybe you logged into Windows, you RDP'd, and you ran a bunch of batch jobs, you started the database broker, or you restarted the replication server, and then, well, okay, it's time to log out. You did your work, you chose the sign out option instead of the shutdown option, but this will in fact crash a database. Again, if it's processes holding on to a latch, it's the same thing as running a kill or a task task scheduler end task and effectively crashes the database. The next way to crash a database is through excessive BI growth. Basically having your BI file grow so excessively that it fills up all the space on the disk drive, and then the database just crashes. There's no more room to grow and everything just stops. Then you're scrambling with your Windows or your Linux system admin or infrastructure, trying to scramble and get that extra space added just so you could bring the database down. Not a pleasant situation to be in, and a situation that could be avoided. Now, there's some common misconceptions on what the BI file is, what the BI is in progress, which I hope to clear out. So first off, we're talking about before image. We're not talking about business intelligence. And what the BI file is basically a way of the database of maintaining its integrity. So any transactions that have been committed or haven't been committed yet are written in the BI file. And it does this so that if ever there's a crash in the database reads through the BI file and brings it back to a normal state where the database could be used again. So it's a very, very essential part of the database. But unfortunately, there are some events that can cause it to grow excessively and fill the database up. Some possible causes: a largely scoped transaction. So a piece of code that's written that's very largely scoped, locking too many records at once, processing too many records at once, and causing that BI file to just grow exponentially. Another more common one is a long-running transaction. So long-running transaction in the database can cause the BI file to grow excessively. Now, some things to consider to prevent that. There is a parameter in progress called BI stall and BI threshold or bit hold. So what these parameters do, when the BI file reaches a certain threshold, instead of crashing your database and filling up the space, it'll stall. So what's dangerous here is that it behaves like a crash, and if the database administrator or the person managing the environment is not aware of them, you can end up in a pickle because the database will look like it crashed, but it hasn't actually crashed. So if you do decide to put those features in, you need to be aware of them and know what actions to take so that the database does not stall. Now, progress gives you a warning, a nice little last-minute 90% warning that you're about to reach a threshold, which is unfortunately not very helpful. Even if you're constantly reading the log file, the BI file can grow so fast where you won't have a chance to go in and remedy the problem and kill that long transaction, kill it safely. So what we recommend is monitor your BI usage. So a tool like Protop, even the free version of Protop, could monitor your BI usage and tell you how much of your BI file is being used. Even though your BI usage fluctuates throughout the day, your BI size will never go back down unless you do a BI truncate. But even if your BI file has reached 2 gigs at some point, and you want to get an alert at 500 megs, you can set up that alert so that you'll get alerted when it reaches that threshold. You don't have to wait until the next time it starts growing beyond the 2 gigs. So this is what's nice about it. Next way to crash a database is by reaching the lock table high watermark. Now, anyone that's worked in progress long enough has seen this error message come up many times. And normally a seemingly harmless error message, you'll get a lock table overflow if the database basically ran out of locks. If there's a user that locked too many records, more records than beyond what your lock table is set to. So for example, if your lock table is set to 50,000 and one of your users tries to lock 60,000 records, well, he's going to hit the high watermark at 50,000 and he's going to get the lock table overflow error. Now, what many people don't know is that eventually, if this happens often enough, the database will crash. And the reason for that is because every time you hit that lock table limit, the lock table overflow, in order for progress to continue to be able to function, it'll actually increment that lock table overflow, that high water mark, by 1. So if you were at 50,000, you're going to be at 50,001, and then the database will continue to run. But what most people don't know, and what I didn't even know myself, is that in order to increment that lock table, Progress needs to borrow from its shared memory pool, from its excess shared memory pool, that MXS parameter. And every time it does this, it runs out of memory. It uses that memory, and eventually that shared memory gets exhausted, and then you end up with an error message like this: they're out of free shared memory. Now, there's ways to mitigate this. You want to be monitoring your lock table high water mark. You want to make sure that you're always within the lock table high water mark, that you're never hitting it. And if you are hitting it, well, you need to make some adjustments. And if you get to a situation where you have reached it and you have increased it, well, you could also increase the MXS parameter, the excess shared memory, online. But the best thing to do is avoid it and monitor your lock table parameter. The next way to bring the database down is by doing something as innocent looking as changing a host name on the server. Anytime you change a host name on a server with a running database, you will crash the database. And this happened a long time ago. This caused a big crash at a customer of mine a long time ago, where the host name was changed, and it brought all the databases down on the server. But I actually seen it happen very recently, where again there was a communication breakdown. System admin replaced the host name from a simple host name to a fully qualified host name with server name .company name .com, and effectively crashed the database. Now, luckily it was just a test environment, but nevertheless it did bring the database down. Progress recognized there was a host name changed, and the database came down. And the reason for that is because the log file contains the host name, and Progress will recognize that its host name was changed, and Progress will bring the database down when that happens. Now, before we conclude, we haven't even scratched the surface on all these other disasters that can bring the database down, like natural disasters, snowstorms, power outages, fire, flood, earthquakes, cyber attacks, terror attacks, pandemics, all kinds of other stuff that could bring the database down. So it's very important, especially important, to have an up-to-date business continuity plan. You don't want to end up like this over here. Now, what have we learned? We're human. Everybody makes mistakes. We all make mistakes. But when we're working in production, we have to manage these mistakes. We have to avoid them. And we can do that through some situational awareness and some behavior change. Making sure we're following procedures. We have documented procedures, checklists. Also, a good monitoring tool can help mitigate some of these risks that we went over, like the BI growth, the lock table overflow. A good monitoring tool like Protop can help alert you of when these problems occur, so you could deal with them before they bring the database down. Now, I am offering a free trial. Contact me and I'll be happy to set you up. Also, stay current. Continue watching these webinars, look through blogs, learn from the mistakes of others on avoiding database crashes. And finally, have an up-to-date disaster recovery plan. Make sure you perform your backups, but it's especially important to test your backups. Make sure your backups are actually working. If you haven't tested your backup, you don't have a good backup. So, very important. And now I'll be taking your questions. Thank you very much for attending my session.
That was fun and informative, Nectar. Thank you so much. Next month, we are excited to have Robert Cohen and our own Christian Manga take us through a Dynacast case study. It's a quick look at real-time machine downtime capture tool from which Dynacast continues to reap some pretty cool rewards. That ought to be a good one. And then Don Lindsay returns in June for fixed assets, and he is back with us again in July for supplier performance. So that is May through July, and let's circle back to today with Nectar. And I'm looking, okay, I don't see any additional questions, but again, back to Nectar's shared lessons about some nightmarish things he's seen. So we should all keep in mind that in addition to awareness and preparedness, learn from the mistakes of others, as Nectar said. You can't live long enough to make them all yourself. And I'm checking again, as I said I would. And Nectar, I don't have any additional questions, but is there anything else you wanted to share with us today before we close out?
Nope, that's it.
Okay, so again, we will get the Encore email out to everybody as soon as we get today's session published. You'll be able to contact Nectar directly through that, or just shoot us an email, Nectar or any one of us at 32Soft, or give us a call. Thank you, Nectar, so much. It was a lot of fun having you with us today. And as always, thank you to everyone who took the time out to join us. We hope we do see you again next month. From all of us at 32Soft, Nectar, thanks again, and have a great day. Keep safe, everybody. Bye-bye.
My pleasure. Thanks for having me.